start. Okay.
Hi, good morning. So, welcome to this live session, and this is on sensors and actuators. So, if you have any questions, do let me know, and I'll try to answer to best of my ability. Okay. So, we already started, right? First question: when we will start? So, we started. Yeah. Hello, Tilokesh. So, what's the question? Sure, Akshay. Bhargava, sir, can you suggest some referable books for this particular course? See, there are many books which you can refer, Bhargava. However, I what I taught in this course is a gist of lot of books as well as some practical experience that I bring with me about 10 to 15 years that I worked in this field. So I kind of believe that rather than looking at the books, you should look at multiple videos that are available, and that will give you a much more different kind of perspective rather than just reading a book. Okay. However, a very standard book that people used to read is from Botkar. So there's a VLSI technology by Botkar. This is what a standard book we used to read, but that is long back, and things have changed drastically. Of course, the fabrication techniques remain same, but the application and the new area of research continuously changes, and that's what I tried to show it to you in this particular course, that how we can use the sensors and actuators fabrication knowledge for using for different field. And one of the application we taught was in the biomedical space. So Akshay, yes. So is there any commercial non-invasive technology available for diagnosis of diabetes or cancer? No, there are no commercially available technologies. However, there are multiple companies who are trying to bring this non-invasive technology into the field. Uh, the breath signature are extremely important. Just we discuss about diabetes. In particular, diabetes we discuss about ketosis. So ketosis is where the ketone bodies are higher, and that's why the breath concentration would have a fruitier smell because of the higher concentration of acetone. However, when you talk about cancer, in particular breast cancer, then you will find that there are several volatile organic compounds present in breath. So, is there a way to capture those VOC or delineate that VOC? VOC is volatile organic compound from the breath. If you can do that, then I think that will be extremely novel and very useful screening tool, because right now the if you see breast cancer, the screening is mammography, and mammography is not only painful but it also has some side effect because it uses X-ray, right? So being a clinicians, you can say, and they are interested in this kind of technology. So to your first question, that are there any technologies available? No, there aren't, and that's why this space is open for researchers like us to barge in and to find out the alternative techniques. Okay. What are the hinderness? See, you need to have a vast amount of patients, large cohort of patients. just a few hundred samples, 200 samples will not work. You'll go for 10,000, 20,000. And the difficulty of this, particularly from Western countries, is they don't have that many samples available. For us, we don't have commercialization facilities, right? We don't produce anything, and that's why when you see the initiative by government, Make in India program, what is it? That we should fabricate things here, so that once we have devices, once we have technologies, we can use this because we have large cohort of subjects, right? We can use it right over here, and that is the beauty of our country. We have a huge amount of patience, and now slowly and gradually we understand that how we can develop technologies indigenously right in our country, right? So that is the hindrances, because you require a large cohort of patients. Okay, the more about shape memory alloys. Sure. So shape memory alloys are made of nitinol, and they are particularly used for maneuvering the robotic arm. So let me give an example. If you see your breathing pipe, right, it's called trachea. So trachea, there is a bone here, and that's why it looks like, if you can see my finger. Okay, so this is a trachea, and then you have to move the trachea in this particular fashion, all right, like this. And when you have to maneuver the catheter within the trachea, then you need to train your shape memory alloy so you can retain the shape. So for example, if you take a shape memory alloy and make a spring and then heat it at particular temperature, let's say 400 degrees centigrade. Now you straighten it up and you again heat at 400 degrees centigrade, it will come back to its original shape. That means it recognize or memorize the shape on at which it was trained and that particular temperature. Right, so that is the shape memory alloys. Even though it is a new topic, generally shape memory alloys are used in robotics, surgical robotics in particular, because it is easier to have the rotational factor to the robot, which is right now difficult to have. When I say rotational factor is 360-degree rotation. You can have multiple degrees of freedom or many degrees of freedom, but when it comes to rotation, it is very difficult. So that is the advantage of that one. Then the next one is Shivam. Even I had a question: what should be my ideal career with a background in EE to pursue MEMS research? Actually, MEMS is a very integrated subject. You require a background from electrical, electronics, mechanical, mechatronics, robotics. You know, sometimes material science, sometimes chemical engineering. So you may have seen one of my teaching assistant, Arjun, teaching you some of the actuator courses, right? Some of the actuator labs. So he has a mechanical engineering background. So it is varied in terms of what kind of application of MEMS we are looking at. So I don't think that you should just if you have a background in E and if you have very clear understanding about electronics, because MEMS itself is something that you need to learn. You have to go in the lab and fabricate the things, learn each and every technology. For example, if you talk about PVD, then you have to learn thermal evaporation, E-beam evaporation. If you learn about lithography, then photolithography, E-beam lithography, right? You learn about etching, then dry etching, wet etching. So this is, I don't think lot of universities, at least in our country as well as lot of countries, they have this laboratories that can teach this particular subject in terms of practicals. Of course, you can learn this thing in theory. So by default, any student who joins my lab or who joins MEMS group, they have to go to the lab and learn it. The only thing is the basics should be clear. Okay, so if you have the basics clear, it will be easy for you to apply and learn new techniques. Okay, what type of sensor will be used to detect lung cancer? So there is not a particular sensor. If there was particular sensors, then it would be so easy. See, if you say about nose, does human nose have only one sensor? No, right? It has an array of sensors. An array of sensors connected with the neural network that makes the effectiveness of our nose. That means one single sensor cannot be selective and sensitive as well. A group of sensors, when you use in an array form, and then you train it for different concentration of VOCs, and then you have to test it, so that you have to train your algorithm, and that is what we call machine learning algorithm, right? Of course, you can use some statistical analysis like PCA and DA, which is called principal component analysis and discriminant analysis. going forward to machine learning algorithms which are already available. You have to modify a little bit depending on what kind of sensors you use. But instead of a type of sensor, I will say that array of sensors, and if you go for nanostructure based or metal oxide nanostructure based sensors, then the sensitivity would be higher because of the surface to volume ratio is higher in nanostructures compared to the thin film. So that is what I would say. There is no single type of sensor that can be used for detecting any disease. Okay. And we are talking about this from the breath signature point of view. All right. Can you provide PDF notes of the lecture version? Yes, yes. So we are creating kind of the lecture notes, and which is we call transcripts, and it will be available to you. I think the NPTEL group from Madras is leading this. So we are working on the lecture notes. So whatever lecture I have taught, it comes in the times of writing, and then we are correcting it, so you can just look at it and go back and see. Okay, so let me go to next topic, and that is from Tilokesh. Career as an IoT architect. I would like to start IoT hardware designer, please. So, Tilokesh, how about this? Can we talk this offline? Because IoT is a little bit different than what I work on. There are very good scientists and engineers and professors who are working on this particular domain in my department as well as in the institute. So I think I will not be a right person to comment right now. However, if you send me an email, I will be able to answer your question. Since this is particularly meant for our live session discussion for sensor and actuators. So sorry about that, but you can always contact me through email, Tilokesh. Let me go to next one, Sanjeev. Why does proximity sensor need temperature sensor? Whether all type of proximity sensor has a temperature sensor in it? I don't think the temperature sensors are required.
These one specific type of
Yeah, and so yeah, so I think Sanjeev, there was this little bit of maybe the miscommunication or misunderstanding. The example that was given was a type of proximity sensor with a temperature sensor. However, we not every proximity sensor has temperature sensor. So to answer your question in a very simple manner, no, proximity sensor doesn't require temperature sensor. There was just an example in which you had that temperature sensor integrated onto that. Okay. Robots that are used in medical. Yes, of course, Madanikar. We can use the shape memory alloys, and they are used in micro robots for medical applications. Next one is, can you explain lift up techniques? It's not lift up, delay. It is lift off. LIFT-OFF. Okay. Can you explain it? How I don't have anything to explain it right now, but let me try to put it in the easiest form. All right. I am holding a mobile here. Okay. I'm holding a mobile, and if this my hand is a layer of photoresist. Now you see I have patterned the layer in this format. That means you can see the gaps in my here, right, in this particular. So you assume that this is a photoresist. This background mobile is a substrate. Now if I deposit any material on this layer, all right, and let's say I deposit a metal, and then if I dip this wafer in acetone, what will happen? This photoresist will get lifted off, right? So photoresist will be developed. When you develop the photoresist, what will happen? That the metal on this photoresist will also go along with the photoresist. That means the metal on this layer will stick, and metal on the photoresist will be lift off. That's how we call lift off. Okay. But again, if you don't understand with this example, I can get a better example through an email. Okay. Can we go for the next one? Yeah, that's all. It's not lift up, it's lift off technique. Assignments will be helpful for external exam. Yes, of course, Uday. Assignments are meant so that you can get better understanding. Don't always correlate your every assignment or homework with your external exams. It is more like a learning, right? How you can solve the different questions posed in the assignment, how you think about it, and when you think it thoroughly about the solving the particular questions asked in assignment, it automatically helps to improve your understanding about the subject, and thus it can definitely help you to answer well in your external exams. Okay. But I really don't believe that we should correlate assignments or homework with our external exams and even marks. It is more like if you learn things thoroughly, if you enjoy the subject, you will do well in any subject that you take. Okay. Uh, Tilokesh, my email ID is there on my website. You can just check it. It's a bees lab at IISc. Okay. In the 3D jetting printing, how can we do multicolor? Yes, we can do for multicolor printing. If you just Google it, it will be easier, Sanket. It is a lot of information already available. It's not something that new things that we have taught about 3D metal jet printing, but we want to bring this in the domain that there are metal printers available which can do 3D printing, because most of us we still feel that only polymers can be 3D printed, but not anymore. There are 3D printed 3D printing machines for metal as well. Can you give example for micro robots that uses shape memory alloys? Okay, so right now there are multiple companies who are trying to work on the MRI compatible robots, as well as robots that uses shape memory alloys. However, none I think are there in the market right now. They are in the clinical phase study. So that is the answer. Why does consumer need temperature sensor? Whether all types of no. So that is, I already discussed this earlier. Srivi Daikasti, sorry, my pronunciation if it is wrong. No, not all the proximity sensors will have a temperature sensor. We don't require temperature sensor in all the proximity sensors. There was just an example given when we explained you in the practical class, that the temperature sensor with proximity sensors you can use, but you don't require temperature sensor with proximity sensor every time. So does proximity sensor have a temperature sensor in it? Answer is neither true nor false. It is some sensors they have, some sensors they don't have, but in general if you want to answer just one out of true or false, you can say false. Okay. Can we operate 3D printer from a distant place? Yes, you can. You can operate 3D printers from a distant place. And we already, I think we discussed this 3D printer, right? Octoprint. So the Octoprint is a software which we use for operating 3D printer from a distant place. Okay, Shivam. Next question is from Shivam. Malanikar, I hope I can answer your question. You got it right. Octoprint, Octoprint. That is a software that is available. Okay. Okay, Shivam, sir, what should be the ideal PG course and university for MEMS specialization, but for PhD in physics? I cannot comment from the university point of view. I am not in a right position to comment from which university are equipped with or which are not. But what I understand, as far as my understanding about MEMS technique goes, that IITs, some of the IITs, they have the MEMS specialization course, and they have the facilities, including of course IISc. In when you talk from Indian perspective, okay, and what you should do is you should learn the MEMS technique. For example, if you learn VLSI fabrication, VLSI technology, then you will be learn how the silicon wafers are fabricated. What is the process technique for fabricating the integrated circuit, right? In that you will be taught everything. For example, if you fabricate silicon from silicon dioxide, there are two techniques: float zone technique and Zagorski technique. If you have to grow silicon dioxide, thermal oxidation. You have to deposit different layers because you are diffusing the material for creating the MOSFET, right? Which is an integrated circuit. Or part of the integrated circuit. Then you will be learn how to use diffusion and implantation. You will learn how to do lithography to open the window. So that way, if you take the VLSI fabrication courses, then it should help you in MEMS application. If your university or the university that you have applied for doesn't have the MEMS practical or space for you to fabricate MEMS based devices. Okay. Sir, do we have lengthy questions to write in external exams? No, it's not there. Only objective types. I make my questions and exam paper very easy. If you understand the course thoroughly, you will be able to answer and get 100 on 100. I want every one of you to get 100 on 100. Okay. So let me go to next question. But for false, I got an answer as incorrect.
Because whatever we thought.
Because that was specifically from the course that we asked. But if in external exam when we asked, we will specifically mention that whether proximity sensor will require an integrated temperature sensor, you should answer false. Okay, but that was only specifically related to the experiment that we taught. That's why you got this answer. Okay, don't worry about one incorrect answer. Yeah, it should be kept. Okay, next one is Bolare. What is the scope of electronics and communication engineering in future for this course? I have out of 7 students in my lab, 6 have electronics and communication as a background. So that's the scope. Bola. Sanjeev has a question. Can we measure electrical, thermal, and mechanical properties of the tissue simultaneously using ETM? Yes, you can. You can measure all 3 properties simultaneously. However, I will put in this way. First, simultaneously, I'll say with some millisecond difference, because if you press the sensor, then mechanical, and you apply the voltage, then electrical. These two can be done simultaneously. When you go for thermal you have to heat the tissue. So while you are heating the tissue, you should not measure mechanical and electrical, because the heating itself will cause a change in these properties. That's why E and M we can do simultaneously. T you should do in space of few seconds. So that's the answer, Sanjeev. I already answered this Srishti earlier, that if you understand the VLSI technology fabrication courses, you take a book from K.R. Botkar. It has all the details inside it about the fabrication of integrated circuit, and that will help you to get the things clear.
There are some Google forum questions there.
Yeah, 1 second. Malanika, let me ask some of the other questions as well. Since I'm answering all the questions that are there right now, but there are a lot of people who have asked through Google form. So let me quickly answer those people as well. Kalpana Selam, she's a faculty. She is asking, can we use a device, or can we design a device which screens the drug for lung cancer? No, I don't think that. Yes, we can. Of course, yes, we can design a device, macrofluidic device, that can screen the different drugs, specifically from patient-centric point of view for lung cancer. And I taught you a macrofluidic platform for drug screening. Let me answer the second question. From Kalpana again, sir, can we design a macrofluidic channel device to help farmers to screen farmers to screen different fertilizers? See, there are endless possibilities of designing a macrofluidic system or chip. There is no restriction. However, we have not tried with different fertilizers, so I will not answer that question with 100% surety. Until you test, you don't know. Okay. Let me ask second. Let me answer second question from G Praveen Kumar. He is a student. Is there any lecture materials you can provide? Yes, I already said that we will be providing this one. It will be through transcript that NPTEL provides. What are you telling in a statement in the video and making 0 for the question you have asked? Clearly said by you in the video. I don't get it, G Praveen Kumar. Why don't you send me an email which or you can ask in a forum which exactly statement that we said and you got 0. Okay, don't feel disheartened. The question is, the exam is for 100 marks. However, I don't want you to feel disheartened. Just let us know which question you felt that we have answered or checked in a incorrect method. Okay, let me go to next one, which is Sanket, and it says that firstly, thank you. Okay, it was nice to learn how it memorizes shape. We already discussed about shape memory alloys, so I hope that you can revise that thing, or you have attended this particular live session, Sanket. Sanket, you are asking, please provide mock test. We cannot do that, Sanket. It's not how the syllabus is formatted from NPTEL. Again, if NPTEL provides you any kind of new syllabus in which there are mock tests, then I can provide. So I think the better person, the better people to ask will be the NPTEL organizers from IIT Madras. So you can shoot an email to them and let me see if they are allowing the mock test. Okay. So other questions are from Sachin, then Dama, then Vishnua, then Saraswati. They are all asking about providing the materials. So we will do that. One of the students say that please make it short and simple. I cannot make it more shorter and more simpler than this, right? If I make it too technical, it will be difficult for you to understand since it's a different topic. Okay. Um Let me ask the last question because we are running out of the time that we have allotted, and that is from Akshay. Akshay is asking, can we develop a standalone device like lateral flow device and give primary but instant diagnosis of disease? It should be available in market. So that yes, you can. Then that's why what I said is you can design a macrofluidic chip for drug screening. One, macrofluidic chip for antibiotic susceptibility. Second, so this can be used at the oncopathologist in the hospital, not next to the patient, but in the oncopathologist lab. Alright, so yes, yeah, the questions are very relevant, and I hope that you got the answer. You can devise this macrofluidic chip. Okay. Alright, so I think this is the end of this particular live session. I'm sorry if I have missed a few questions which were asked, but we will try to ask the remaining through the NPTEL forum. Thank you.